Hello and welcome to another tutorial on multi-threading in Java from caveofprogramming.com, and this tutorial is on semaphores in Java. So I'm going to start by creating a semaphore object here equals new semaphore like this, and I'll give it an initial count of 1. And a semaphore is a object that maintains a count like this. This is the count. And we refer to the count as the number of available permits of the semaphore, and you can get the number of available permits by saying semaphore.availablePermits. Pretty simple. So this has 1 permit. Now there's a method that increments the number of available permits, and it's called release. So if you call release now, I've got 2 permits, and of course I could start this with 0 and release would make it 1. And there's also a method that decrements the count of available permits, which is called acquire. So if I start with 1, release 1 and acquire 1, I've got 1 by the time I finish. Or if I start with 1 and acquire 1, then I've got 0. Pretty simple. And the point of this is that acquire will actually wait if there's no permits available. So let's say I've got no permits here, and I call acquire. This will just wait until a permit is released somewhere, and I'm not releasing a permit, so it will just wait indefinitely. And so you can think of this as acquire and release for a semaphore with 1 permit is a bit like a lock. It's a bit like doing lock and unlock on a lock. And indeed, you can use this as a lock. So a semaphore with 1 permit is basically a lock. And the only difference is that you can happily release from different threads to where you did the acquire. So with a lock, you have to unlock from the same thread that you locked from, but there's no such requirement with a semaphore. Now, what semaphores are usually used for is to control access to some resource. So let's say you have well, let's start coding that and see how it would look. What I'll do is I will create a connection object here. Let's call it connection, like this, connection, and I'll make this a singleton. So I'll make the constructor private connection, like that, and I'll give it a static, I'll give the class an instance of itself, so private static connection instance equals new connection, and I'll have a method for retrieving that that instance. So public static connection get instance, like this, return instance. So this is just an absolutely normal singleton pattern, and I'll give this one method as well, which I'll call public void connect, like this. And connect doesn't do anything at the moment, but now in my main program, of course, I could call connection.getInstance.connect, and there's only ever 1 instance object at any given time. There's only ever 1 connection object at a given time. So the idea is here that you can make connections to this connection. So I'll give it a private count, private int count, and this is going to be the number of connections that are made at any given moment. So actually, maybe it's better to call it connections. And then in connect here, I'll just have a synchronized block, synchronized this, let's say, and I'll increment the number of connections like that, and then let's output it here as well. So current connections, like that, and I'll say connections. And I'll also when you exit the connect method, I will just decrement the number of connections currently made. And in the middle here, let's just simulate doing some work here with thread.sleep. Make it sleep for 2000 milliseconds, let's say, and let's just handle that exception here with try catch. So now if I run this, I just connect. It says one connection, and then it exits. Now in my main program here, I'm going to create a massive bunch of threads. So I'll use executor. I'll use an executor service like this, executor, and I'll say that equals executors dot new cache thread pool like this. And a cache thread pool is just a thread pool which every time I call submit on this executor, which I'll do like 200 times, so I++, I'll say executor.submit. It will just create a new thread for me, and it would try to reuse threads. So if it was able to reuse a thread that had become idle to run one of these processes that I'm submitting, it would do. But here I'm just going to submit 200 all at once, so there's not going to be any reuse of threads, I don't suppose. So I'll say here public void run like that, and what I'll do is I'll just call this connect thing in here. So I'm creating 200 threads here, and I'm trying to call connect from all 200. And one thing I need to do here is I want my program to terminate when these threads finish. So I need to call shutdown on the executor to shut down a managerial kind of thread after all these threads have finished running. And I'll also wait until they finish by saying executor.await termination, and let's make it wait for a day, which is long enough. Okay, so this is just running 200 threads, and if I run this, you see I've immediately got 200 connections. So let's see how I can limit the number of connections at any given time. And the way I can do that is I have a semaphore in here. So private semaphore sem equals new semaphore, and let's say I want 10 connections at a time. So to make a connection, you've got to acquire one of these permits, and after the connection's finished, it will release a permit. Now what I could do, and what I can do, and what I will do in fact, is I can say here semaphore.acquire. So this acquires a permit before it can run, and let's just put that in a try catch, because it throws an interrupted exception. And when I finish kind of running this connect method, I'll release the permit again. And so now if I run this, you can only get 10 connections at a given time, and when one of these finishes, it will release the permit, and then another thread can acquire that connection. So this is doing it in batches of roughly 10, because they're all finishing at about the same time. Now one thing here that is not quite right with this code is that if this code here were to throw an exception, then release might never get called. So it's safer if let's have a new public void connect here like this, and let's rename this to do connect, and here I'll have my semaphore.acquire code in connect here, and I'll say try, and in here I'll do my do connect like that, and in a finally block here, finally, I could have my release code here. So I'll take this out of here and put this in the finally block, and now even if my code in here throws an exception, the finally block will still run, and it will still do release. So one last thing I want to mention about semaphores here is just that this semaphore object constructor has a fairness parameter, and if you have a fair semaphore by setting this to true, then it means that whichever thread called acquire first will be the first one to get a permit when a permit becomes available. And if you don't have true there, then that is not guaranteed. So usually you probably want a fair semaphore here, so you probably want that to be true, or I think there are performance benefits to having it equal to false, but most of the time you will want it to be true, because you don't want it to be kind of leaving some thread in the background while it services other threads, and you don't want like one thread to have to wait ages and ages to get a permit when other threads are getting those permits that have been waiting for a shorter time. Okay, so that's it for this tutorial, and join me again next time, and you can find this code on caveofprogramming.com. So until next time, happy coding.